Hello, today we are going to take a look at this absolutely beautiful dental polishing machine. Basically, it is like a Dremel multifunction tool, but for your teeth. Most likely it was used to remove like a stain or maybe for making a prosthetic. So yeah, I'm not sure what was the intended use case, but I know for a fact that we can use it in our electronic lab for a lot of different applications, and the only thing that we need to make sure is that we've got the correct tip size. If you take a look at the front panel, we've got a lot of different adjustments, so it is a little bit more complicated than similar looking devices that are made just for doing your nails. We've got ability to control speed, to start and pause our motor. We've got ability to change direction. We've got digital readout of the speed. We've got the RPM, but most likely I can see only 2 wires, so most likely it do not have a readout from the motor. And we can control it by hand or by foot. And if we decide to use our foot, then we've got pedal like this that is going to be attached into the bag, and now we've got hands-free operation. We can control it by foot and we can see and focus on what we are doing. This handle is quite heavy. That piece is made out of metal. I'm pretty sure because that was like a medical device, we are going to get zero or tiny minimal movement, because on the cheapest one you are going to get lot of wobbling. Here it is made in very professional way, so I'm pretty sure it's going to get a absolutely beautiful results. And this is how it's presenting. It is quite heavy, so I will assume it's going to have like a regular transformer. Here you've got the model number. We've got the CE marking, or it is a China export, I'm not sure. It's got generic name of electric drill. And let's try to power it on. And let's see what is the problem. For this repair we are going to be using different power station. So here we've got our AC socket. Let's try to power it on. And as you can see, device power on. We've got RPM on our speed, and we've got ability to adjust it. And as you can see, we've got a multiplier. So that's going to be at 10,000. We've got forward and reverse direction. And I can hear the relay clicked. So it is absolutely beautiful. It reverses it by a physical relay, not by a semiconductor, the H-bridge. And we've got the hand and foot control. And as you can see, when I depress it, it is starting motor, but we've got that fault indicator. Let me go into the hand operation, and I will try to start it. And nothing is happening. Nothing is spinning, so yeah, it is pretty sad. And looks like here we are going to get our problem, because that do not look promising. Someone was trying to fix it, but it looks terrible. And if you take a look here, we've got a DIN, full-size DIN, with a 5 pins. That plug we've got only 3. So someone was trying to force it and most likely rip it. That do not look like a genuine plug. Of course, in my assortment I've got a lot of different DIN plugs, and we are going to find correct one, so it is absolutely not a problem finding a 5-pin DIN. Here we can connect it, but I'm pretty sure it is being ripped from the PCB, and we need to open it and check all the traces, but I think we are going start from seeing that part, and we are going to check it out. Why we've got this 5 pinned in? Maybe it's got a readout for our speed on the RPMs, because it could have like a sensor. Let me try to open it up. That plug is quite interesting, because looks like it is glued together. So either someone cut it and fix, or it is from different device. Those 3 pins are quite interesting. I will cut it, and we are going to see the wires inside. I was trying to do that by hand, but it was painful. We go like this, we click it, and it's done. This is why you have to buy this. And we've got extremely good news, because we've got just 2 wires. So that's going to be extremely simple job. By the way, the wire looks absolutely amazing. It is made out of those strands. A very similar one I seen on like a military handset. Just take a look. Very good quality. This kind of cable is not prone to breaking with a heavy use. So maybe it was expensive and high quality. I think it is proper time to just try it out. So I've got my power supply. Let me double check the voltage. Output, we've got 30 volt DC. So yeah, let's go to 15 volts. Half of that. Let's limit the current to 1 amp. Since it's reversing it, we should have absolutely no problem in attaching to any polarity. It can just rotate in the wrong direction. And let's see, will it work? And as you can hear and see on the power supply, it's working perfect. If we go like this, we should just reverse the direction, and by the movement of the head, looks like it's working great. So the most expensive part and complicated to fix, it's operational. Let's try to open it. I hope those are the only 2 screws, or they might be holding transformer and we might have got screws there. But let's hope for the best. Let's pray that it's going to be that simple. And yeah. Oh, it don't want to open. So maybe that was transformer. Let's try to pull those. And we've got something. We've got more screws. And let's see, will it open? And yes, it does. Just take a look. This is how it's presenting. Here we've got our DIN socket. We can see that it's being ripped off. Let's see the transformer. And yes, this is what we would like to see on like a medical device. We've got a beautiful real transformer that is giving you a great isolation. We've got our relay. Everywhere we've got a heatsink, beefy capacitor. Yeah, this is what I would like to see. We've got inline fuse. Yeah, this is a nice device. Properly made. Just take a look. So let's take a look what's going on, because we've got those 5 pins that were looking really scary, but they are not. So those are just to give it support. The central one is to give stability, it's not connected to anything. And those 2 pins are tied together to give a more current, possibility to pass more current. And yeah, it is extremely easy. So we are going to be bridging them in my beautiful plug. So here is a 5-pin DIN. We are going to check them out and we are going to bridge them together to give ability to pass more current. So let me try to fix it. Terrible story, I do not have 5-pin DIN, so yeah, I will not be able to fix it today. But we are going to solder those pins and we are going to fix our plug and we are going to make sure that this device is operational before I order the correct part, because of course I will not leave it as is. As you can see, it is broken and it's not holding together, so yeah, I will not allow something like this. Once again, I'm not fixing it, I'm just making connections so we can try it out. That's going to be replace, desolder, and make the correct way. But now we should have connection there, and we should get power. And here is our DIN plug. We are going to insert it the correct way, just like that. And I will grab multimeter and we are going to see which pins need to be bridged together. Let's see if that makes visual sense. So I will bridge those 2 pins and looks like they did it. And other side, and the center one, I would say it's going to be that one. Yes, it does. It was manufactured in a very smart way. So let me prepare that part. And of course, something that we are going to forget, you have to put it first. And I learned that hard way so many times. Then now I remember. Let's try to add a little bit solder there. And of course we are going to cut it afterwards. Yeah, that looks beautiful. Let's make those strain soak. How does it present? In my personal opinion, beautiful. Just like that, I like it. And if I attach it wrong, then nothing happen. We just reverse the polarity and I will redo it, but we are just making test, so those 2 pins are going to be together. And now we are joining them here. We go like this. And we go like that. So keep in mind, this is just a test. We would like to see if this device is operational. So I will close it down. Let's try attach it to my power station. And we are going to see, will it work? We operate it by hand and I will press start. Forward direction. And it not doing anything. It's working. Let's see, can I adjust speed? Yes, I can. Can I change direction? It stopped. It clicked. And it reversed. And so looks like it's working. Looks like I will have to order just the replacement socket, that is a DIN one, and we are going to get a beautiful fix. Of course, I will have to correct it because this is not the way I will release it. So we see ourselves in next month. 2 packages later, we can continue our repair. The first elements are those PCB 5-pin DIN connectors that just arrived from China. I purchased them on the AliExpress, and we've got this absolutely beautiful, I hope exactly the same footprint, so we are going to be trying to replacing it. Second package, also from AliExpress, is this beautiful set of different grinding attachments, and as you can see, we've got lot of different kinds, starting from brush to like a files with those quite interesting, that looks like a bismuth. This is a quite interesting, of course, I mean the color one. And we've got like a more regular one that you can find on like Dremel. And those are shining like they've got like diamonds filings inside. So yeah, it is quite interesting. We've got a lot of them because I've got no idea which one is actually a good one. That looks like a ceramic. It is quite sharp, but maybe, I don't know. Yeah, I've got whole set, and let female choose the good one. Let's begin with our PCB. So we have to take a look at our board, and this is where we stop. Let's take a look. Do we've got the same dimensions? Yes, that looks pretty. The pinout look exactly the same. So let's try. So as you can see, we nicely desolder it, and it came out right through. Here someone was trying to fix it. It wasn't me. So we have to clean it out. Let's remove that element. And of course it was nicely desoldered. And here we've got some glue. The last thing what I absolutely love with fixing Chinese device like this is that they are using generic components that are easy to source. If that would be something made like in Europe, then we would get trouble because it will be like a non-standard item, and here it was cheap, so they just buy it locally. And if everything goes well, then we should be able to just push it I think there was a little bit of glue, and looks like it fit perfectly well. Just take a look how beautiful it is, and we just need to solder it. And here we are with the thermotronics, and it should be absolutely beautiful. Amazing job. Just take a look how beautiful it is, and easy to work. Just take a look at this. This is so beautiful job. It won't budge. Absolutely beautiful. Let's try to clean it up. When I'm working with isopropyl alcohol, I love this bottle, and I highly recommend you checking my video about it, because it is really great. And now we can nicely clean it up from rest of the flags, because I've got no idea if it's no clean or not. Let's make it nice and clear. Just take a look at this. This is a professional job. After cleaning, I think it's time to put it back. The design is really nice because we've got access to our PCB quite easily. And we go like this. Here our wire. And it should go like this. And now we have to put our screws. We've got 6 screws to put in. And we are going to be using that Parkside this time. Okay, that looks absolutely beautiful. And prior to gluing back our screw, let me add our feet. Of course, looks like I misplaced one of those feet. Absolutely horrible. Prior to sealing up the connector, I'm not going to be even crimping it because I might have wrong polarity. So we are going to be plugging in like this. Maybe it is not very elegant, but there should be a safe voltage. We need to put tool into our chuck, and the visually pleasing should be that brush. Here is our chuck that we need to rotate to release, and we can actually, it was already open. So we go like this and we close it down, and now it cannot be removed. Then of course we are going to be grabbing my power bank, and we are going to be plugging ourselves in, and we are going to be starting the inverter. And as you can see, the device power up. We are in the hand mode. Of course, we are going to be checking the foot switch also. We are in the forward direction, and from the picture, it should be rotating like this. And let's start the motor. We've got nothing because we need to set the speed. And it's spinning, so I will dial that down. And I can clearly see that we've got a correct direction. This is the correct direction. Let's reverse it. And it is a correct direction. So that part looks absolutely beautiful. We can of course go the full blown. Since directions are correct, we need to crimp it up, so pulling on the cord will not rip it out, so we go like this, and we nicely crimp it up. And I like to add some glue to make sure if the wire become loose, it's not going to make any short, but this is my private thing that I like to do. As you can see, I added glue and we can put it together, so that hole need to go on top of that element, and we need to close it down so it nicely clicked in place, and I start to create mess. Here we've got that element that is pointing out, and it's going to be catch in that hole. So we need to just slide it like this. And as you can see, here we've got that element, and I like to pull it a little bit. So let me grab something sharp. This can be anything. We go like this, and I nicely make it sticking out. And now if we try to pull it, as you can see, it's being locked and it will not fall out. So let's try to connect it one more time. We go like this, absolutely beautiful. We start our motor. We set our speed. And as you can see, it's working absolutely beautiful. And here I notice that we've got our foot. So we have not lost anything. We've got 4 of them. So as you can see, by replacing those 2 broken elements, we make this device operational again and save it from going into landfill. So thank you very much for watching. I hope you find that interesting. See you next time, and bye bye.